and welcome back. So in this part we're going to focus on our game control script. So double click to open it up, and just if this message come up, just click reload, click yes, and let's get started. So at the top, let's make some public variables. So in Snake there is a maximum size of your snake. So we're going to create a public integer, so click max size, public int max size, and also need a current size, so public int current size. Now to go back to what I was saying in the previous video about public variables being able to be used across other scripts with easy access to change data, and also in your inspector, I'll prove this by firstly adding the game control script to the game controller, and if you see, the max size and current size has come up. Okay, we also need to call our snake prefab to be able to instantiate it. So create a public game object and call this snake prefab. We also need to create a reference to head and tail of the snake, so public snake head and public snake tail. We also need an integer for our north, south, east and west directions, so public int and call this NESW on capital letters. This will be used in our switch statement later on. We also need a public vector 2 and call this next position. So this variable eventually will be looking for our next position on the map, and the vector 2 is representation of 2D vectors and points, which you can see if you hover over the vector 2. So it focuses on the x and y, where vector 3 focuses on the x, y and z. We also need to be able to check for the boundaries as well, so create a public int and call it x boundary, and also we need to check for the y as well, so semicolon public int y boundary. We also need to check for our food prefab, so public game object food prefab, and we also need to check the current food on the screen, so public game object current food. And then eventually we'll be adding the source, so public int score. Okay, that's our public variables set up. So first thing we're going to focus on is creating a switch statement for our character or our snake. So we need to create a new function, and this will be called movement, and this is where our switch statement will be. Okay, so a switch statement goes through, it loops around the method. Beg your pardon. It switches between different cases in your method. So you'll see soon enough that it will switch between cases known as NESW, which was set up earlier. So in the parameters you put in the variable NESW. So to start with, we would have a new case, and we'd call it case 0. So this case would focus on north direction, so up. So with that case we'd put in our next position, which is equal to a new vector 2, and it checks for our next position on the x and our next position on the y plus 1, and then we break that case, like so. So what's going on here is in this switch statement, excuse me, in this switch statement, our case 0 handles the position of north. We know that because we're creating our next position with a new vector 2. We do nothing on the x because it's going up. We only focus on the y, and it's by +1. So our case 1 on the list is east, or left in this instance. Right in this instance, should I say, sorry. So, this would be case 1. Cases, this could be as many cases as you wanted in this switch statement, but they always start on 0. So you could have 25, it would start on 0, so the last number you would have as a case would be 24. So case 1. Next position equals new vector 2. Next position, and because it's going right, we need to focus on the x. So next position dot x +1 unit, comma next position dot y. So we do nothing on the y, and then we break that case because we don't want to add anything else. So case 2 and 3 can be done quite easily. So case 2, I'll just break that case first, and case 3 I will break as well. And then all we do for our south is that for our south direction, which is 2, case 2, we just copy and paste here, Control V, and instead of +1 it is -1 digit. And our case 3, copy this, Control C, and again it's -1 because it's going in the opposite direction. Okay, so below, still in our switch statement, we need to instantiate a new cube in a new position when it moves, essentially. Snake works on a type of grid format, so once you move once, it then needs to create another object in that position. So temp, that creates the sort of grid movement that you see in Snake. Temp equals, so we need to create a new variable and call it temp, temporary for short. Oh, sorry, this is in the wrong place. It shouldn't be in our switch statement. I do apologise. It needs to be below this bracket in our movement function, I should say. So create a new temp variable, and this is equal to a game object, and this is where we instantiate our prefab. So we're looking for our snake prefab, its next position, and its transform dot rotation. Okay, and then we set our next version of the snake's head. So remember, we set up that in our snake script, set our next snake head, and then we get our temporary temp dot get component. So it's going to get our component, which is our snake script. Open close bracket. Miss something out here. Give me a second. So snake equals game object, essentiate snake prefab, next head dot set next temp. In our movement script, we're missing a couple of things. We're missing the game object to set this up, and we're also missing our next position, which is equal to our head dot transform dot position. Apologies about that. So we need to create a new game object first to be able to instantiate our prefab, and we also needed to know that our next position is equal to our head of our snake plus as well as the transform position of it. Okay, so semicolon here. Okay, and we need to say that head is equal to our temp dot get component, and we're looking for the snake component again. Open close bracket, semicolon, and then we need to return this statement. So that goes to the top and continues. Okay, we also need now to focus on the input of this game. So at the moment we've set up our cases to check if it's moving north, south, east and west, and to also create instantiate game object when it goes to its next position. However, it won't do that until we input, until we have some input. So we need to create a new function, call this void change direction. Open and close parentheses. So we're going to focus on going up first. So if our north, east, south, west variable is not equal to 2 and the input dot getting key down, so this is checking to see if our key is down, and that the key code is W. This could be any key, by the way, that's up to you. And in here we need to set that our switch statement, our case for moving up, is set at 0, because you see case 0 sets our new position going up, so we need to make sure that when W is pressed that it goes up. Okay, so if any SW is not equal to 3 on our switch statement, and the input dot get key down, key code equals dot D, then that would be any SW equals 1. So to save time, I'm just going to copy one of these, Control C, Control V, copy, paste, paste. So that would be now 0. So if it's not equal to 0, then that is equal to 2. If that is not 1, then that is equal to 3. And obviously change these accordingly, so that would be S, and that would be A, like so. So that has handled our movement. Control S to save as well. Okay, what we need to do now is we need to update this movement. However, we want this updating at the start. So we need to do some time event, so over time it moves as well. Okay, so we need to create a new function, and we're going to call this void timer invoke. So in here we're going to call our movement variable. Actually, I'm going to put this above my other functions as well, so it's more neat. So I'm going to just put it below our update function, so just there. So I'm going to call the movement, and in here we're also going to check if our current size is greater or equal to our max size. Okay? And we'll call our so we'll leave that as it is for now. We've got to create a tail function before anything goes in there. And we need an else statement here as well. Else, keep adding to our current size. So what this if and else statement will do, we'll check to see if our current size is greater or equals to our max size. If it is, we need to create a function to say that no more shall be added, else keep adding our current size by 1. So let's create that tail function first. So I'm going to click here and go void tail function. I'm going to call this snake, so we're grabbing our snake script, calling it temporary snake, and setting that as equal to its tail. We're also going to say that tail is equal to tail, and it gets the next in line. So dot get next, it returns the tail essentially. I'm also going to say temporary snake and delete the tail. Okay, so that tail function is saying it's our temporary snake is equal to the tail. Tail equals tail dot get next, and the temporary snake will delete the previous tail if our current size is greater than max size. So in here we just call that tail function. Oops, wrong one. Like so. Okay, so to get this updating, we also need to have that update in here for our input. So in here we put change direction, and in our start function we need to repeat our switch statement, which is in this timer invoke. So to do that we need something called invoke repeating. So timer invoke in quotation marks. Let's put invoke one there. And after this we need a comma, 0, comma, dot 5f. And what this means is that after 5 seconds it will constantly go through the switch statement checking for input every 5 seconds. Oh, actually it will create, my bad, after 0.5 milliseconds it will go in the grid one unit in the grid every 0.5 seconds. So it starts, 0.5 seconds moves, 0.5 seconds moves, without you adding any input. Okay. So next thing we need to do in this is that we need to check our food, and we need to create random positions for our food. So create a new function, call it void food, parentheses, and we need to create random positions for this food to spawn in. So create a new int and call it x position. So it's checking our position on the x value. Call it random dot range. What that does is check a random range in the area that you set. So we want it minus our x boundary, and on our x boundary like so, and the y position, so we want it in between the minus of our x boundary and in our x boundary and our y one. Int ypos equals random dot range minus y boundary a boundary, like so. Next, we need our current food to instantiate on the screen. So remember we set a food prefab, we need that actually appearing on the screen as well. To do this, we could type in current food is equal to a game object and instantiate our food prefab. And we need to create a new vector2 somewhere on the screen, which is our random x position and our random y position. And it also needs to have a transform dot rotation. Okay. We also need to check that the food is visible on the screen as well. So to do this, we're going to create something called an IU numerator, which is basically a coroutine to check certain times between certain times when an IU numerator is used to start coroutines of a script. So once an IU numerator is called, you need to also have a coroutine. So for this instance, we're creating an IU numerator to check for the end of the frame for our render of our food. Okay, so once you go over the food, anything tagged as food, it will delete that object and add another one, because we don't want loads being rendered at the same time, and the coroutine will check to see the render is there of our current food. So we need to, in the parameters, game object in. Okay, we need to yield, return, and create a new, and we need to call this wait end of frame. So it waits until the very final frame when the object's deleted. So if in dot get component our renderer of our food, check to see if it's visible. So dot is visible, and if it's false, so if it's not visible, so equals false. Missed something off here. Second. No, I spelled yield wrong. That's it. My bad. There we go. And in here we need to check if in dot tag is equal to food, then destroy the renderer. And also, so that destroys our renderer, but also we need to call our food function to restart the cycle again. So food, call the food method. So in our food method, we also need to start this coroutine of our render. So start coroutine, call the check renderer. If I call it check render, yeah, check render, and then our current food is what we're looking for. So, okay, we're nearly done with this. Okay, so what we need to do next is create an on enable and on disable to check to see if the snake is hit, if it's enabled, or if it's disabled. So just above our start statement, we need to create void on enable. So this checks to see if our snake is enabled or not. So snake dot hit plus equals hit. So it gives us a hit, checking to see if we're enabled. Okay. Oh, that should be a capital O. Okay. Also need to check on disable, so create void on disable, open close bracket, parentheses, snake dot hit minus equals hit. So this will disable our object eventually. I put git, I meant hit. Okay. So it looks like I'm missing something currently. So let's just have a look what it is. We need to create this void actually for our hit. So we've got it at the top, however we don't have a function to say to enable this or not. So just here, let's type in void hit, make a string, what was sent, open close brackets, if what was sent equals food, we need to call our food function to say it was hit, to add a new one, and we need to increase our max size by 1, like so, and we also need to increase our score, like so. So up here on enable, it will tell us if our snake hits anything. It will come down, check this function, add another food, check the max size, and also the score. Okay, Control S for that. Go back into Unity, make sure there's no errors, and check to see if there's any errors in the console. And there isn't. So, in the next part, we'll get the game set up, and we'll go from there. Okay, thanks for watching.